Alright, Precalculus Concept 19C. We're going to be talking about some basic properties of logarithms. So there's a couple things to kind of watch out for. Hopefully they're kind of common sense. We'll start off with two basic properties of logarithms. Anytime you have log base b of b equal, and you want the answer, it's just going to be 1. Couple examples of this. If you had log base 2 of 2, you're thinking about 2, your base, to what power gives you 2, and the answer is always going to be 1. So if these two numbers match, the answer will always be 1. Okay, similarly, if you have log base b of 1, the answer will always be 0, no matter what your base is. I'll pick base 11. If you want to raise a power to 11 and get an answer of 1, it's going to be the 0 power. So a good way to think about this one, b of any b to the 0 power equals 1. And when you see those, either of those versions, those are quick, easy problems you should be able to figure out. Alright, box 2, we're going to talk about the inverse of a logarithmic function. So we're going to start by asking the question, what is the inverse of f of x equals log base b of x? Hopefully remember the process for finding inverses. We're going to make it a y equals expression. We're going to flip-flop our x and y and change this into an expression like this. And then I want to solve for y, and that's a little tricky, but if we remember that every logarithm can be rewritten, I'm going to change this to my base b raised to the x power equals y, and just by rewriting this we actually have solved for y. So my inverse function is b to the x. Right? This is actually a really interesting result and something that's very important to remember, that logarithms of base b and exponents of base b are inverses. Okay? Something also very important to remember is that if you compose a function with its inverse, you get x. And so this is actually very helpful to remember whenever you see a logarithm and an exponent with base b and you compose them, they're going to basically undo each other and get you back to what you started with. So a real quick example of that, we'll look at a couple more on the next slide. Log base 2 of 2 to the 7th would be an example of a exponential expression of base 2 and a logarithm of base 2, and you're plugging the exponential expression into the logarithm. You're going to undo what you started with, and so your answer here would be 7. And this also makes sense in thinking about it the way the last slide talked about, 2 to what power equals 2 to the 7th, but it's also a good little shortcut to remember. Alright, a couple more examples on the next slide. Alright, these 4 examples all look kind of challenging, but the key is to recognize that we've got inverses in every example, right? So, y equals 2 to the x and y equals log base 2 of x are inverses of each other. And so if I have a logarithm and I plug it into an exponential expression like I did over here, they're going to undo each other. So log base 2 of 10 is some number. 2 raised to that power is going to reverse what you started with, and your answer is 10. So when you recognize that inverse function relationship, these become problems that don't require any work at all. Okay? 7 raised to the log base 7 of 3 is, you guessed it, 3, because you are composing a logarithmic expression with an exponential expression, both of base 7. Okay, it works the other direction too. So log base 5 of 5 to the 4th, this time you're sticking an exponential function into a logarithmic function. They're both base 5, they're going to undo each other, and your answer is 4. Last one, log base 3 of 3 to the negative 2. Once again, a composition of an exponential and a logarithm with the same base gives you negative 2. Okay. Quick side note, you want to make sure that the bases do match. You can't do this trick unless you are working with the same base b. Okay, 3 U-tries. These should be pretty easy if you kind of understood the properties we've talked about in the last couple slides. Log base 5 of 5. Pick the best answer. Alright, the answer is 1. Couple ways to think about this one, but if you have your base 5, you're thinking about the power that you would raise to get an answer of 5. So a quick little check would be 5 your base raised to the answer 1 should be the thing that you're taking the log of, which is 5, and that definitely checks. Alright, try the next one. 2 raised to the log base 2 of 6. Okay, your answer should be 6. This is an example of a composition. You've got y equals 2 to the x, and you've got y equals log base 2 of x. These are inverse functions of each other. And so if I take a logarithm and I stick it into an exponent, it's going to reverse it and you get 6. Try the third one. Okay, another situation of a composition of inverse functions. Once you recognize that, the answer is 1